Hey everyone, hopefully you can hear me on this video. I apologize for the last one that I posted Monday morning. Apparently when I did the screen recording, the microphone wasn't on, so my apologies. All right, let's get into the lesson, okay? I think it'll make more sense now that you can hear me. We are dividing radicals today, and that is often referred to as rationalizing the denominator. Because if you have a radical in your denominator, chances are it's an irrational denominator. And if we clear that radical, we're taking it from a irrational number to a rational number, hence rationalizing the denominator. So you'll notice my directions here, they say to simplify so that there's no longer a radical in the denominator. Let's start with 2 divided by the cube root of 5. I'm presenting this as a fraction, and again, we just want to clear the radical from the denominator. To do this, I'm going to multiply by a clever form of 1, okay? And I'm going to be strategic about it. I'm going to choose to multiply by the cube root of 25 over itself. Okay, now I think we can all agree that the red fraction equals 1, and that means when I multiply the original fraction by it, I'm not going to change the value of the original fraction. Okay, so that's very important to understand. And then also make sure you understand why I've chosen 25 as the part that's underneath my cube root in the clever form of 1. The original radicand is the underneath the cube root is 5. Okay, if I multiply that by 25, that's effectively like multiplying it by 5 times 5, right? Which is going to give me 5 to the 3rd power, a perfect cube. And once we take the radical into account, the radical will clear, okay? So multiply the numerators together. That'll give you 2 cube root of 25. Multiply the denominators together. Initially, that'll give you cube root of 125. And the numerator doesn't simplify at all, but the denominator, cube root of 125, we know is 5. Now we are simplified. Okay. Next problem, I have the 4th root of 3/8. First thing I'm going to do is break that up into the 4th root of 3 divided by the 4th root of 8. And this time, the clever form of 1 that I'll multiply by is going to be the 4th root of 2 over itself. Okay, now why did I choose 2? Well, if I take 2 and I multiply it by the 8 that's already in the radicand of the original denominator, that's going to give me 2 times 3 more 2's for a total of 2 to the 4th power. Notice the index of the radical is 4. And that's going to clear then. All right, so multiplying 4th root of 3 times 4th root of 2, that'll give you 4th root of 6. Down below, 4th root of 8 times 4th root of 2, that'll give you 4th root of 16. Numerator will stay the same. Denominator will become 2. Now we are rationalized. Okay, on your file, you don't have the next set of examples. I chose to put these in after I made the lesson and got it out to you guys. So if you just want to, if you get out of your writing tool, remember you can add sheets by just clicking the plus sign in the top left there. And then you can delete the table by selecting the circle that's at the top left corner of the table, hitting delete, okay? So why don't you do that, and then you can copy down these next 2 problems, all right? These 2 problems, you're going to see it's going to be helpful to simplify your radicals before you end up trying to rationalize, okay? So 2 divided by the cube root of 24. The first thing I'm noticing is that cube root of 24, it can simplify, okay? 24, if I make a factor tree, that's 6 and 4, 2 and 3, 2 and 2, so that means 24 is 2 times 2 times 2 times 3, notice there's three twos there that I can pull out, okay? So that means I can simplify this to 2 over 2 times the cube root of 3, okay? Now once I do that, I can get these these 2's to reduce to 1's. And that just makes things a little bit simpler for me. I now have 1 over just the cube root of 3. Okay. Now I need to multiply by a clever form of 1. I need to take the 3 that's in the radicand of the denominator, and I need to make it a perfect cube. I can do that by multiplying by the cube root of 9 over the cube root of 9. Okay. So that's going to lead me to the cube root of 9 over the cube root of 27 over cube root of 9 over 3. Now we are simplified. Okay. All right, next problem, we have 4th root of 4 divided by the 4th root of 32. And there's a couple ways you can approach this, but I'm actually going to make it one big radical again. I'm going to make it the 4th root of 4 over 32. And when I think of it like that, I can actually reduce the fraction here. That becomes a 1, that becomes an 8. So now I'm going to break it back up. I'm going to think of this as the 4th root of 1 divided by the 4th root of 8. Okay. Now I can simplify. 4th root of 1 is 1 divided by the 4th root of 8. That doesn't simplify, and this is where I try to rationalize. Same as the previous slide, you have the 4th root of 8 in the denominator. If you just multiply it by the 4th root of 2 over the 4th root of 2, you'll create a perfect 4th power in the denominator. Okay, so this is going to simplify. 4th root of 2 over 4th root of 16, which becomes 4th root of 2 over 2. Simplified. Okay, now let's look at a couple problems where we have some variables within the radicals, okay? Here I'm going to simplify so there's no longer a radical in the denominator again. And I can approach this very similar to how I did this on the previous couple examples, okay? So square root of y to the 8th divided by x to the 7th. First I'll break that up. Square root of y to the 8th divided by square root of x to the 7th. And I am going to try to simplify here now. Square root of y to the 8th just becomes y to the 4th, right? And then square root of x to the 7th, I'm going to have to think of x to the 7th as x to the 6th times x. Square root of x to the 6th is x cubed, and then you just have the square root of x left over. Okay. Now I rationalize. Okay. I'm only focusing on the part of the radical or part of the denominator that's in the radical. So right now I'm focusing on the square root of x. I ask myself, what do I need to multiply that by to make the radicand a perfect square? And the answer is just square root of x over square root of x. Okay, so that's going to give me y to the 4th square root of x in the numerator over x cubed times the square root of x squared in the denominator. Okay. And I have y to the 4th square root of x over x cubed times x. And that's going to give me y to the 4th square root of x over x to the 4th. And we are now simplified. Okay. All right, now notice in that approach, if we go back and we look at from the beginning, I chose to simplify the radicals right away before I did my rationalizing. Okay, and I could take a different approach. Okay, I could start with square root of y to the 8th over square root of x to the 7th. And I could have just multiplied by square root of x over square root of x right away. So that's going to give me square root of xy to the 8th over square root of x to the 8th. Square root of xy to the 8th will simplify to y to the 4th square root of x, and then the square root of x to the 8th simplifies to x to the 4th. Okay, so that would be a different approach that leads you to the same result. All right, last one here. So notice this one I have a cube root. Let's break this up. Cube root of 2 over cube root of 9x. Okay, think about what can you multiply 9x by that's going to make it into a perfect cube. And the simplest would be, let's use cube root of 3x squared over cube root of 3x squared. Okay, that's going to give me cube root of 6x squared in the numerator over the cube root of 27x cubed in the denominator. And that'll give me cube root of 6x squared over 3x. Notice the radical is clear now in the denominator. And we are simplifying. Okay. All right, so now it's your turn. You're going to move to practice 2 on your own. You're going to pause the video, try them yourself, and then when you're ready, come back to the video and check your work.